using FileReader and Bufferedreader, and this is kind of the old way of reading files. And you can read files using the scanner class, which is a bit less cumbersome. And there are also some new language features in Java 7, which we're probably going to look at in the next tutorial, that make this a lot nicer. But the stuff that I'm going to show you here at the moment is still really important to know, partly because it will still work even if you're using Java 6, as many people are, and partly because this is at the beginning of 2013 anyway, and partly because you can change the code that we've got here and adapt it so that it will read files in all kinds of different formats, like binary format or a different kind of text format to the standard. So what we're going to write now is very flexible, even though it's cumbersome. So the first thing is we need some kind of text file to read, and we're just going to look at text files here. And I won't repeat the remarks that I made in the tutorial on reading files with Scanner about where to locate your file, but I'll just create a file. I'll right click the project and create a file here in the project folder called test.txt, which we're going to work with here. Rather than specifying a full file path, I'm just going to put it where the program can find it easily. And let's put in here first line, second line, third line, and that'll do. And I'll save that, so it's just a text file. And I'll create a file object that can read that file. Let's say file equals new file and test.txt. So the file object is a platform independent way of representing a file that doesn't depend on any particular kind of path specification. Like, it doesn't care whether it's forward slashes or backslashes in there or whatever. It just represents your file on any system. And then we need to read that file, so I'm going to use the FileReader because the file represents the file, but it doesn't provide you with convenient methods for reading it. So I'm going to use the FileReader, and I'll call this FR. And usually I don't. Usually it's bad practice to use two letters for a object in Java. You should spell it out more than this. But we're only going to refer to this really temporarily, and this has become such a kind of idiom in Java that it's not so bad just to use two letters in this particular instance. And I'm going to pass the file to the constructor of FileReader and do Ctrl-Shift-O to add the import for FileReader. And now FileReader will try to open the file, but it throws a file not found exception if it can't do it. So let's handle that exception by surrounding with try catch. I just click the error there. And here, let's say sysout file not found, because if you're going to distribute this to an end user, they don't want to see a stat trace. They want to see file not found so that they know what the problem is. And it's also crucially important to say what file has not been found. So let's say file.toString to get the file name there so the user can see what file has not been found. Because if a program just says file not found and doesn't tell you which file, from the end user's point of view, that's a total nightmare. How are they ever going to know what file that is? So you should always tell them which file has not been found. Now FileReader lets you read the file, but only in a quite inconvenient way. If you want to read it line by line, you also need another class, because this only lets you read it so many chars at a time, let's say. What we want to do is we want to save up the chars that we read, the characters that we read from the file, and we want to process them one line full at a time. And when you kind of save data up like that and process it in useful kind of bytes, then that's called buffering. So we want to do buffering, and to do that we want to use Bufferedreader here. So Bufferedreader, let's call this br equals new Bufferedreader, and we pass in fr, the file reader, for it to work with. So that's three classes there, like a kind of Russian doll thing, and I'll add the import there. So we've got Bufferedreader on top, and then underneath that FileReader, and underneath that we've got file. And I'm going to declare a string here and this is just a reference. I'm not going to actually create a string, and this reference is going to point to each line in the file in turn. And to do that, well, I can do stuff like line equals bufferedreader.read line, and that throws another exception. It throws an IO exception. So let's click the error here and go to add catch clause to surrounding try to add another catch clause, and then here I can say sysout unable to read file and file.toString. So in the first case here it can't open the file, and here it could open the file, but for some reason it's just not able to read it. It's corrupted, or it's got the wrong permissions on it or something. And if I now do sysout line, and I run that, we're going to see here I can't actually find the file. What did I do wrong? I called it text.txt. Let's right click that and go to refactor rename, and I want to actually call this choose destination. Okay, something's going horribly wrong. What I'll do is I'll just copy that and close that and delete it, and let's just recreate it with the right name. So right click the project, new file, test.txt is what I wanted to call it. Paste the stuff in there, save it, run the program, and now we've read one line from the file. We've read the first line. So every time we call bufferedreader.read line, we're going to read one line from the file, and we want to actually read all the lines from the file, and to do that we have to enclose this in a while loop, and we want the while loop to stop when the line is equal to null. And we can use a kind of slightly strange feature of the Java language to accomplish that. We say while, and there's the opening bracket of the while loop, and we put this whole thing, the actual reading of the line itself, in round brackets, and we say while that is not equal to null, and then close the bracket of this while loop here. So if you put this whole thing in brackets like that, that evaluates to whatever was assigned to line here, and we're checking then that that is not equal to null. So this is not really intuitive, but it does the trick. And then finally we can put the brackets on the while loop, and we can move this sysout inside the while loop like that. So now we're going to read the lines from the file one at a time, and we run that, and we see we've read the lines from the file. And you could use it would be inefficient to have like one big string and to do plus equals and concatenate these lines to a big string, because once you create a string, it's immutable and it never changes. And when you use plus equals with a string, it's actually creating a brand new string every time. So if you wanted to collect all your lines in one place, and you have to be careful of memory considerations if it's a big file, but you should use a string builder to do that rather than using plus equals with a string. Now the outstanding and remaining problem here is that we haven't closed this buffered reader, and we might get problems potentially with open file handles if we do this a lot. I'm not sure if Java will actually close it automatically. Possibly, but certainly if you were reading a lot of files in your program, then you need to close them to avoid memory leaks and stuff like that. So if you see this warning here, it says BR is never closed. Now the question is, where do we close this buffered reader? If we close the buffered reader, it will automatically close the file reader, and I don't know if file technically needs closing, but it will close everything up the chain above it. So we only have to close this last one. We have to call the close method, because this is opening the file, and we want to close it again by calling bufferedreader.close, which closes this, which also closes this. But where do we call bufferedreader.close? If you put it down here, bufferedreader.close, br.close, then we've got a problem, and it's going to say that BR cannot be resolved. And that's because when you declare a variable in Java, the scope of it is limited to the curly brackets around it, and this is declared within these curly brackets, so it doesn't exist down here. What we need to do is declare this outside of those curly brackets. So I'm just going to do Control X and I'll just put BR here. So I've cut that to the clipboard, and now I can paste it up here, and let's put the semicolon in and save it. And now the error has changed. If we look at this, it says unhandled exception, type IO exception, because close can bizarrely fail, and in that case it will throw an IO exception. So let's click this, surround with try catch, and we're catching the IO exception. Now there's still a problem. Let's have a look at that, and it's saying the local variable BR may not have been initialized. So we haven't, if we throw an error here, if this throws an exception, we never execute this line, because when you throw an exception it immediately goes into the catch block down here. So then that wouldn't have any value, and then we're trying to call close on something that has no value, which we can't do. So we can make it shut up by saying BR equals null, and then it goes quiet and it looks fine, and if we run it then it's fine. But supposing it can't open the file, let's add another character to the file name and run that. Now it says null pointer exception, and I click this error here, and this is throwing a null pointer exception. That's because this is throwing an exception, it can't open the file, so this is still null. And what it's telling us, what Java is telling us, is that we're trying to call close on something that's null, which gives us a null pointer exception, which we're not forced to handle, but we can handle it if we want to. So let's handle it, and we could add another catch clause here to catch null pointer exception. But perhaps the easiest thing to do is, well, is it the easiest? It depends on your perspective. We could put a message in here saying can't close file, although the user might not care about not being able to close files. But let's put a message in here and let's say can't, unable to close file, and you kind of have to decide whether it's worth telling your user about that, because most users of software, if they see a message saying can't close the file, well, they didn't even know that the file needed closing, so to them that will be an obscure error message. So you might not want to put in an error message there. You might just want to write this to a log file or something. And now we could change this to exception, and because if we throw a null pointer exception, it would then be caught by, if we had this just like this, it would be caught by this as well, but then it would be wrongly saying unable to close file, when in fact the problem was the file could not be opened. So let's not do that. Let's just go here, put another catch in, catch null pointer exception X, and let's just say here, well, why should we say anything? So let's not. And usually you should put something in here when you handle an exception, but in here it's likely that this is being thrown because the file was probably never opened. I don't see how that could not be the case, really. So yeah, if the file's not open, this will throw a null pointer exception because it'll still be null, but we'll catch it here. And let's run that now, and now we see it says file not found, and there's no further errors, which is very nice. Although of course if you put x.print stack trace in here, then you would see the error. So we haven't got any print stack traces in here, so we're only seeing our own custom error output like these, which is good. So now this works, and now if I delete this character here, then we can run it. Now this is all good, but if you follow a university course in Java, or if you look at a lot of books, they will tell you to do it slightly differently, just because here I'm assuming that you want to handle the error and print stuff out here, but you might actually want to rethrow the error. This code is probably not going to be in your main program, and it might be in some method somewhere, and you might want to throw the error again here, rethrow the exception, or even throw a different exception here to signal further up the stack, further up the hierarchy of method calls that something has gone wrong, and you could handle this somewhere else with a dialog box or something. So you don't always want to just catch this here and then carry on to execute this. You might want to exit your method with another throw here or something like that. And what we can do is we can put a finally block in here like this, and finally is always guaranteed to be executed. So whether this runs okay or whether one of these lines throws an exception, the finally block at the end here, at the end of the catch clauses, will always be executed every time. The only way it won't be executed is if, let's say, there's a nuclear explosion which vaporizes your computer, or more likely your computer stops working. But if the program executes successfully, this will be run even if exceptions are thrown. So let's just move this into the finally block, and this is usually how you'll be told to do this on a university course. It will usually look like this, and now we've got the same thing as before, and if the file's not found, then it just gives us a nice error message. So that's it for this time. It's a hell of a lot to absorb, but this is a very flexible way of reading a file, and in the next tutorial I'm going to show you how you can use Java 7 to simplify this a lot and really make it a lot nicer. Because if you think this is clunky, you're absolutely right. It looks really like well, it looks like a pig's ear or a donkey's ass or a rat's nest almost. Perhaps not a rat's nest, but it is ugly. And this is one of the worst things in Java, the way that the exceptions tend to get nested and tend to build up and clutter your code. So there is a language feature in Java 7 that we can use to simplify this, and we'll look at that in the next tutorial. But that's all for this time, and this code will be on caverprogramming.com. Until next time, happy coding.